And for the particular case on the HPCC on Amazon Web Services, we are trying to do efficient loading of the data that are residing on a simple storage system or S3 on AWS. Particularly the files that we're targeting are compressed files that include multiple XML records in them, or multiple XML files, each file including like thousands of records. So what we're going to do, and we have been working on, is a distributed operation on those files, basically loading, decompressing, and spraying off those files or putting them into the memory where they need to be and on the disk if that's what's desired. So first step that we do is still includes some shuffling of the data, but eventually we're going to get rid of that as well. So this is the process that is currently being done. So the file being loaded from the S3 on the landing zone, and it's decompressed. So basically you have a file, multiple XML files inside it, your archive, and then be put on the Thor cluster. That Thor cluster is residing on the EC2 on AWS. The current approach that we are taking is to do a parallel load and on-the-fly decompression of the data and then extraction of the records, and either direct them to a Kafka-based distributed file system sprayer that exists with the HPCC right now, or directly put them to the through a custom module to the Thor memory. So at this point, we're currently working on approach 2, and then we'll go to the approach 1 after that. First step of the development has been to first distribute the landing zone and the spraying. So we've currently implemented the operation of parallel load, decompression, and the spraying of the XML files from S3. And then each node on the Thor, so instead of having one node doing that, so you have multiple nodes that directly connect to S3, read your records, XML records, and files, XML files from that archive, and decompress them, and then put them on their own node. And then, because those files need to be distributed, we have a distributed spraying happening at the end. We are load balancing those operations to make sure that everything is happening in the most optimized way. And we're using a library called Message Passing Interface, or MPI. Most of you might be familiar with it, for the communication. The step 2 will be to skip that communication altogether so that everybody is just doing a completely data parallel operation where you can directly load your records on yourself without requiring any extra communication. So this is what's happening right now. There is a multi-file zip archive. Multiple nodes do that, decompress, and do the shuffling at the end. Some preliminary numbers on what we have seen so far on implementing this. So these are 3 graphs that are similar because they are the results on using multiple, like different file sizes, loading different file sizes, 160 meg, 640 meg, and 1 gigabyte. So don't go into too much details there. I'll explain everything here. So what happens is that we have listed all the different steps that are happening in the operation and have compared the case that you use the single landing zone versus the distributed spraying. In this test case, we have used 4 nodes on the EC2, so we have 4 Thor nodes that are performing the operation. And for example, here, in the 1 gigabyte data case, these are the steps. So first you load the data from S3, decompress in distributed way, do your shuffle or spraying, and then there's some overhead, miscellaneous overhead, and then your total. So the blue ones are the current one, and the sequential landing zone, and the red ones are the distributed case. So as you can see, in all cases, the S3 load and the decompression are seeing almost linear speed up, which is helping to reduce that time. And then there is third step that is shuffling that data, which is a little bit high here compared to the others, and doesn't see that much of the speed up as the others see based on the number. The numbers are not, you don't see the raw numbers, but from the graph. The reason is that in general, the operation of all-to-all exchange is an expensive operation and is not really scalable. So we are going in the next immediate step to remove this altogether, which is going to save us a lot, and then hopefully this total improvement will go up. Okay, so my last slide is the next steps that we have. So there's a few immediate steps that we're doing at this phase of the work, which is to complete the operation, make sure that, so currently we are spraying to the Thor. We just want to make sure that in the code that all these records are getting on the disk correctly. So that's one correction step that we're going to take. And then we're going to have more data sets to make sure that it applies to different data sets here and works well and is smooth. And then we will, that's what I talked about, eliminate that scattering, which is a big chunk of the time, and further improve that into super linear, hopefully, speed up. And then we will integrate this module into our big picture of the virtual data integrator, and then have other modules develop after that. So in the second phase, we'll hopefully make sure that things get integrated into the HPCC version, and we're also thinking of in-memory spraying and data processing as a new feature to be added.